Welcome to my home lab. Here we are testing or demonstrating the 5 to 10 volt voltage regulator. I designed the voltage regulator using here's my circuit here. I designed the voltage regulator using a full wave bridge rectifier there from an 18 volt transformer. Would have liked to use a 15 or possibly a 12 volt transformer. Preferably 15, but they didn't have any available, so I went with the 18 just to be sure. Voltage is a little bit higher than I would like, but it all regulates down just fine. And then we've got our op amp and our current boosting transistor and our current limiting transistor and foldback transistor or foldback resistor network. And then here we've got two potentiometers. The one on the left there is the voltage control potentiometer, and the one on the right there is our load potentiometer. And so go ahead and set it here, and we can see that right now we're getting about, roughly or just under. Now this here is measuring the current through the load potentiometer, and the oscope is measuring on channel 1 the rectified input, which is measuring at about 31 volts, and the regulated output, which there is 10.16 volts. It's that measurement right there. Go ahead and turn down the voltage control pot. The voltage control pot is currently at its maximum value, so that's our max voltage there. Go ahead and crank that down. And as I crank it down, you can see the voltage is dropping. And at its minimum value, we're getting 5.12 volts out. And so it does get it down. Sometimes it kind of goes between 5.12 and 5.04. So I think it's actually more accurately about 5.08 volts coming out there. So the voltage regulation is absolutely working. We're getting the 5 volt to 10 volt output. Now we want to check the current, and this is where we kind of run into a risk here. Now the potentiometer that I have here is only a half watt pot, and so in the range of 25 to 200 ohms, we're outputting over a half a watt, and so want to crank this down as fast as possible, get down below that 25 ohm range to where we actually start losing regulation and getting current limiting. So I'm going to crank this down, and hopefully we don't fry anything. Okay, and that is all the way down at about 3 ohms, and you can see we're getting a current output of 340 milliamps. So the current limiting is working. Nothing is burning. Nothing is getting hot. And there we go. It works. So that is our series regulated voltage controlled, or series regulator with foldback current limiting coming from a full wave bridge rectifier. Oh, there we go. So it did fry the pot. All right. Whew. Okay, so it was working for a while there, and then not quite sure exactly what happened, but I think, I don't know, it fried the pot. It looks like it may have fried the pass transistor as well, so not quite sure exactly what happened with that, but that is, that still may be due to the current through the pot just still being too much for the pot to handle. But there we go. There you have it. And we're back. So after doing some analysis and checking the data sheet for the NTE235 BJT transistor that we have here, it actually makes perfect sense as to why it broke down. My initial concern about the transformer voltage being too high is exactly the problem. It did regulate down just fine when the load was high. However, when the load was down low, we have the short circuit load calculation of the short circuit load current equals the VBE, the 0.7 volts, divided by the K, which is the voltage divider, times R4, which is our current sensing resistor. That calculation comes out to be 340 milliamps, which is what we were getting on the output when it was short-circuited there. However, with the voltage so high, we're getting a 30-volt drop. Now, the data sheet here shows that we have a collector dissipation of 10 watts. And when you take 30 volts and you multiply it times 340 milliamps, you get 10.2 watts. So we were exceeding that power limit, which is why it didn't fry right away, but it did fry after about a minute or so of operating in that short circuit current. And so that explains why that fried, why the pot was destroyed, and shows that actually the foldback current limiting was working as it was expected. The voltage drop was just too much and created too high of a power dissipation across that pass transistor either way. So a lower transformer value, the 15 volt or possibly even a 12 volt, would have alleviated that problem.